So we have today Denim with us, like who will be talking about how you can get started with like Envio. And today's live stream is part of the hackathon that we are running, which is like MetaMask Advanced Permissions Hackathon. So if you're not registered, you can check out the link in the comments and you can register and like hack with us. So just a quick introductions, like how are you, Denim?
I'm great, thanks.
You
Um,
wanna I think at this point, like everyone must know you, right? Like it's been your third live
I think
stream with us.
that would be nice.
Yeah,
I'm really happy to give another really quick intro. My name is Denim, pronounced like the jeans. I am one of the co-founders of Envio. I'm currently sitting in sunny Cape Town, South Africa. I have a technical background, so happy to uh, dive into any technical questions and really excited to make it super simple on how to use Envio.
nice. So I'll also introduce myself. Hi, Ayush here. So I lead the MetaMask Smart accounts as a DevRel. Uh, Excited to be here. So let's go through like what is the agenda. We have already talked about like what MetaMask Advanced Permission Hackathon is like and how you can take part in the hackathon. Uh, let's just get started with like how you can get started with the Envio. You can share like what is Envio, what are the different things that you provide, and how can one use it.
Cool. Yeah, absolutely. So super simple. Envio is a tool that'll help you build your application, specifically around data. So the most common use case is you've got your smart contracts, you've got your front end, or even with someone else's smart contracts, and you need to get data from that smart contract to the front end. That's probably the simplest use case, but we'll dive into some practical examples of this. We'll touch some code, but nothing will be too technical. It'll be great if you can follow along, but we will also, I'll share my screen and walk you through everything to simplify things. Envio has some really great accompanying bounties, so it's very friendly to develop on and hopefully win one of those prizes.
Nice, nice. And I think like Envio also provides like different products, right? Like there is Envio, Hypersync, HyperIndex, and
Yes.
HyperRPCs as well, right? Like
Yeah, yeah, for sure. Um, awesome. If we're ready, I'm happy to jump into that.
yeah, let's go. Let's dive into some code.
Sweet, let's do it. All right, I'm going to share my screen. Give me one sec. And what I just was mentioning now was we have three different products. That's HyperIndex, HyperSync, and HyperRPC. Now, HyperIndex is probably the most commonly used tool we have. It's similar to subgraphs, if you're familiar with the graph. It's designed as a framework for indexing events from your smart contracts, putting in, doing some aggregation, saving it into a database, and making that accessible over GraphQL API. All right, so very, very well designed for event-based data. And what makes it really unique and amazing is its speed. It is by far the fastest index out there. This benchmark was actually done by Sentio, another indexer. We felt like it would be the least biased view. And what's quite nice is it's also multi-chain. So I'll show you a practical example of that, and then we'll try on the fly do a live demo of setting up a hyperindex instance and indexing some data. Cool. All right. In some cases, you need to do something a little bit more advanced, or you don't need all this additional infrastructure. And sometimes you can just access the underlying API directly. Think of it a little bit like accessing RPC data. You make a request to the node, you get some data back. Now, Hypersync is really good for that use case, but what makes Hypersync special is its ability to search through a large data set for the specific needle in the haystack you're looking for and return that data to you. So there's use cases of both of these depending on exactly what you're building. And we'll go through an example of both of them. Then just food for thought, there's a third one, which is HyperRPC. It is a read-only RPC that's built on top of Hypersync, which gives you the plug and play of RPC. So you can make simple RPC requests to get data, and behind the scenes, we convert it to a Hypersync query, put that data together, and then send it back to you. All right, let's go through a more end-to-end example.
I think
I'm
like I
just
have a just a
yeah,
question like what makes the hyperindex so fast? It's like 15x faster than the second faster, right? So
yeah, yeah. Really great question. So partly it's because hyperindex reads from hypersync, and we identified fairly early on that one of the major bottlenecks is RPC. RPC was designed for Ethereum, 15 transactions per second, and it kind of worked acceptably then. But we're dealing in an age where there's networks like Monad, which are 10,000 transactions per second, so substantially higher uh, transaction throughput, and hence the requirement for more modern uh, indexing solutions. So underlying is Hypersync why it's so fast. It's our purpose-built Rust node with special modern cutting-edge database technology applied specifically to EVM data. Cool.
nice.
Beyond that, though, there's a couple layers on top which make hyperindex faster. Just think of it in terms of we had this hugely performant underlying engine that can feed into it. And so from the beginning, we tried to eliminate any bottlenecks that slowed that process down. Another example of that is we do a lot of stuff in memory. So, for example, reading and writing to a database can be a very slow operation when you're doing it many times. And so what we do is we read from the database, we have data, we do aggregations in memory, and then in one kind of big batch SQL write, we'll write it to the database. So there's lots of nuanced little optimizations. We would love if everyone listening could send over and give us a star if you haven't already. That's for hyperindex. But let's go through some questions, and please do shoot any questions that come to mind. Let's make this collaborative and go through it together. All right, so I just want to show you practically what this looks like. And I'm going to go to the v4 indexer. So these are all the indexes on our hosted service. And I can come here to the Uniswap v4 one. You can see, I'm just going to turn off admin view. You can see we're indexing 700 million events. So it's a huge indexer across many different networks into this API. And there is a GraphQL API, which we can make requests to get some kind of data points. I'm not sure what I'm querying exactly, but you can see that data exists. Why I like to show this one specifically is it's got a UI. So often kind of indexing data tooling is a bit more behind the scenes. And this is what the judges are probably going to look a bit closer. Keep in mind, I'll do the judging myself, and I will be looking deep into that code. So I really want to see sensible integrations. Here is a nice UI, and you can see that kind of swaps increasing. It's a real-time API, a little bit more tangible to see what's happening. You can see all these swap events coming through live, real-time. It's almost a little bit too fast to look at, so I'm just going to hover over it, pause it, but you can see these different transactions coming through. And in fact, it indexed it faster than Polygon scan. I'll give that a moment to
That was really fast.
okay, there we go. It showed up. Cool. So that's maybe an example of a use case. Let's go here. There's some other really cool showcase examples. So if you play around here, you'll see I showed you this V4 example here. Here are other interesting public repos that you can check out to play around with. And you'll see some of them are tagged as hyperindex, and some of them are tagged as hypersync. In truth, everything is leaning on hypersync under the hood, but at the same time, it is also either using hyperindex as the layer above or directly accessing hypersync. Alrighty, let's go through a practical example. And I'd love to do this demo completely on the fly. So let's ask Osh or the audience if there's any contracts that we would like to index. So give a moment for anything to come through. In the meantime, I'm just going to click around and show what we could possibly do. So since I'm already on Polygon Scan, let's go here. Let's find some verified contract. I'm actually not too sure. All right, let's find something with more transactions. It'll be a bit more interesting to look at. If anyone has a contract in mind, I'd love to hear it.
I think there's also pancake swap
Pancake
or
swap,
cross.
cool.
We can do a cross as well.
Do you say across?
Yeah.
Okay, let's do across. Across is also a good example because let's find the contract address because it's very applicable in a multi-chain environment. But let's see if we can take a look at their contracts. Shall we do Monad? All right, let's just take a look at this. Let's see if it is verified. I think the Monad Explorer has actually changed. I don't know if it's .io. No. Let's try monadscan.com. All right, success. And the contract is verified. Fantastic. Last thing I just want to check is if we have events that get emitted. All right, we've got drained tokens or calls failed. I hope these events don't get emitted too often, but let's give this contract a spin. I don't know what we're indexing entirely, but we will surely find something interesting, I hope. Okay, cool. We seem to have an approval and a transfer event here somewhere. So I'm sure we'll get some events. Actually, I could have just clicked here. Sweet. We actually seem to have lots of drain token events being emitted. All right, so super simple. I'm going to copy this address. Now, really simply, I go pnpx envio init. And one more thing I just want to show you here. If you are following along and trying this yourself, come over to the hypersync documentation over getting started. There is some prerequisites. It assumes you have Node.js version 22 or above, PNPM, and Docker desktop. That helps out spinning things up. If you're working on Windows, you'll need to use WSL. That's one extra caveat. All right, let's give this a go. So super straightforward. I'm going to say enter. And as this goes, it's going to prompt me to give new addresses and stuff. So I've created a folder already. So I'm just going to say, let's work in this folder. I'm working on the EVM side of things. I'm going to use the contract import feature since we got it from MonadScan. We know it from the block explorer. I'm going to type in Monad here, and I'm going to paste in this address. And cool. So it's managed to pull that ABI from the block explorer. And so we now see our two events that we were looking at earlier, calls failed and drained tokens. All right. If I didn't want to choose one of these, I would unselect it, but let's do both. All right. And I am required to, I'm just going to say I'm finished. I'm going to add an API token. Let's go over to the browser. I'm just going to log into the hosted service. I am trying to think how to do this that I don't share my API token to everyone. Give me one
There's
second.
a free API token for you to use.
Cool. So you can see I've copied my token here. I'm coming back to my terminal. I'm going to very quickly stop sharing. I'm just pasting that in, clicking enter, and I actually got an error. Okay, I see the error. Sorry, give me one sec. I don't want to show my.
You need the proof of token.
Yeah. Okay, let me just not. I'm finished. An existing API token. Thanks for bearing with me through these technical difficulties. All right, and my API token is not showing in my terminal anymore. So I'm going to continue sharing my screen. And I'm not going to scroll up too much, but essentially I put in the token, I clicked enter. I unselected one of the events just for demo purposes. And what I have now is you can see I have a series of files and folders that exist locally. Now we'll go through that a little bit just to get an idea of it, but let's see our indexer in action. So I'm going to say pnpm dev. All right. What's happened so far? The init command, we've passed it our contract address, and it's automatically created a indexer for us. The index is fairly simple, and you can see that contract we look at doesn't have a crazy amount of events, so it indexed pretty fast. But let's see what that looks like. So you can see this is a local dev console, and we've indexed all those events. And in here, we can see some of that data, specifically the train token. Now, cool. I have no idea what I'm indexing, to be perfectly honest, but we've just showcased how simple it is to spin up a basic indexer. Now, often what you want to do is you want to do something a little bit more complex. So we'll go through an example of this. Let me pull up the code and we can start going through the code. So first off, if you're using Cursor, let's just make this. If you're using Cursor, there's some really nice cursor rules to help you with the development. So it makes it super simple and quick. But let me pull up this code. All right, so the three files that are usually of interest to us, and this is all auto-generated already, is our config file. So you can see here's where it specifies the contract address, as well as the event and the network ID. We're going to do a really quick and simple change here because we know across is multi-chain.
So if you want to add like a new chain, I just need to update the config.yml and the contract on that particular chain, and that's it.
Yeah, so I can actually show you how simple it is. Let's do it now. I'm gonna copy that code for the extra network. Let's go back and find this contract address. Let's not select monad. Let's select base. Maybe there's more history here. We can open this contract. We can see lots of drained token events happening here. So let me pull this. All right. And what is the chain ID of base? Do you know?
Sorry?
Can you remember?
No chain list. No.
8453. All right. So let's put that in here. And if you're indexing a custom network that we don't support, you can also put RPC as a source. And there's guides in the documentation how you can index off a local blockchain as well, doing something similar. All right,
Nice.
so now we've got two networks here. It's as simple now as saying, all right, cool, let's rerun this. And we should see duplicate contract names detected. I think what I want to do is just do it like this. I'm gonna have a top level specify the contracts. I take this out and I simplify it here to just be the address. And I'm going to do the same here. All right. Sorry. So I know that's a little bit confusing, very similar to what I just did now, but I've just separated the global instantiation of a contract so we can import the same to both networks. Let's give that another spin. All right, cool. And now what we should see is we should see it indexing two networks, as of course we added in the config. Again,
Nice.
not entirely sure what I'm indexing. And you can see base does have a little bit more events, but that was also pretty quick. Cool. Then if we look in our dev console again, we can see both networks are indexed, and we should see some additional data from both sides. Cool. Again, looking at the code, what we've done so far is something quite simple. We've just created, this is what our database will look like. So I can actually show you what our database looks like. If I click on Hasura, The local password is testing. And I can make GraphQL queries here too, but I can actually take a look at the data behind the scenes. So if I click here, we can see our table, and you can see all the records that have been inserted. So pretty cool. This table, this database, is a PostgreSQL database, and it's dictated by what we create here. So I want to create another entity called stats. I don't know, and it's everything is required to have a let's not add all this. I don't know what that is. We're just gonna have a stats entity, and every time we get a drain tokens event, in this case, let's accumulate the amount. So we have an endpoint that we can hit, and it'll tell us the total drained. Okay. Now this stats, I'm going to do it as the chain ID. All right. So you should have two stats entity, one for monad and one for base, and we'll see that in the tables in a bit. Now, when you specify your config for the events coming in, you specify your database structure via the schema, which is what I've done here. And then I come over and I essentially do my aggregation in my event handlers. All right. So every time we receive an event, we're essentially saving this in. The AI is not being that smart, to be honest. So let's do this ourselves. So if it's a repeat run, we're going to try to load in our stats entity. All right. And you can see that red line there because I need to run cogen. And cogen essentially looks at your config file, looks at your database file, and it regenerates your types so that you can handle it in your TypeScript. Alrighty, let's go back to our code. You can see that red line's disappeared. And we want to, I think it's fine. No, we need the toString. All right. So what we're doing here is every time we get a new event, we're trying to load in our stats, our existing stats. Now, if stats doesn't exist, you can see the AI suggestion. We would actually like to create, we need to change it to let. We will create our stats entity with our ID, our total drained, and we'll save it. Okay, I'm going to accept that, and I'm just going to change this to a let, so it's mutable. Cool. Now, this is only going to work for the first time. Other than that, it's not doing quite what we want. So it's a little bit smarter and saying, cool, else we can, yeah, this syntax is a little bit bad, but let's just do this. So if it's a repeat run, we essentially want to add it to the existing entity. So if first time it's getting this, we create the entity. Otherwise, on repeat runs, we essentially update that value. So let me just fix this quickly. So we can say stats equals, and I can use a spread operator here. That's what these three dots are. And that says copy everything from the entity up here, all the properties, the individual properties, but I want to change total drained to be, why is this AI? Okay, cool. All right, and that's essentially correct. Now, in both cases here, I'm going to save the stats if it does exist or if it doesn't exist. So let's just remove this here and make that slight optimization. All right, I hope that's clear. If it's not, just to summarize, we've created a new entity in our database, new table, and we're making the ID its chain ID, and we're trying to capture the total amount drained. Okay, and that's what we're accumulating now on each iteration. All right, let's give it a spin and see if our logic was correct. So because I made changes to the config file or the schema, it'll kind of restart the process. Alrighty, and we got lucky with that contract. Great suggestion. It's really nice and fast to see a smaller contract get to the end. You can still interact with it, but it's nice just to do that quite seamlessly. All right, and if I refresh here, we should see our new table stats. Cool.
Nice.
So if I click on stats, you'll see there's two chain IDs and two notably very large big int numbers.
Which
I
we
don't know.
don't know what make sense of.
Yeah, and it might not make sense because we might be adding numbers that have different decimal places, have different values. But anyway, it was just a showcase example.
Nice. That's really fun to see.
Cool. Alrighty. Um, I think we will probably be a little bit under the full hour mark, but what I'm going to show you next is a little bit more. So that's really just an intro. There's obviously a lot more to it. You can play around with the documentation here and click around. What's really nice is you can see I'm running it locally here, but we do have a hosted service, and it has a free development tier which you can deploy to, so you can play around there. Once it gets to hosting, you can read the instructions here. TLDR, it connects to GitHub. So for every commit you make or push you make, you can essentially opt into that making a new deployment. And it's really easy to kind of swap deployments out, etc. There are some very detailed instructions here with a guide on how to do that on a hosted service. All right,
Nice.
what we covered mostly is hyperindex. And what I'd love to look at next is hypersync. All right. And hypersync can be a little bit more intimidating. It's a little bit more low level. So often what it looks like to work with is a little bit more technical, but often really useful for use cases that aren't well managed by something like hyperindex, or you need to get a layer below and get to nitty gritty things. A very common use case is maybe more for a wallet when you want to index things on the fly. Or I'm not sure if you know of revoke.cache, but revoke cache uses it. Let's see if um, it uses it to fetch data where otherwise it would take too long. Another way of thinking about it is when hypersync is when you know the addresses you want the data about. Hyperindex often makes sense. But if you don't know the address or any user can pass in that address, it often makes sense to use hypersync directly. Now, the demo seems to be playing a bit iffy. I'm glad it didn't happen with our indexer. I'm going to move on for now, and we can do an actual example of this. So let's go to docs. Let's go to showcase. I want to show you stable radar. So as you can see, it's using hypersync directly. And what this tool is doing is it's taking just in a fun kind of visualization, it's looking at all USDC transfers in real time, okay, across many different networks. And you can see the average that's transferred per second. So it's an interesting kind of volume metric, and quite interesting to see a fair amount of volume being traded on Monad, and these transactions are clickable. Now, this could be achieved with hyperindex. We could index all the events, we can have it managed real time, and we can save it into a database. But the data I'm looking for here is quite light. And if I was to use hyperindex, I'd be saving all the data into a database. And considering the sheer volume of USDC transfers, I would be looking at a database that takes up several terabytes of data. So it's, although it is functional and it also is really nice that we can look back in the history, for this specific use case, we're only looking at real time. And so instead of doing all these historical queries, I'm just, again, pre-indexed, nice to see. I'm just looking at the live data. So instead of making that, building an indexer for it from the UI here, I'm making requests to hypersync to get that data. Cool.
So just a question, like, so
Yeah,
you want to do using the hyperindex, we'll basically use the USDC contract address and then just use the transfer
yes,
from to collect all the token, like transfer details.
exactly. Yeah, and that's totally possible. You can do it.
And the speed of the radar, right? Like, does it mention the block transaction processing of the chain?
Um, The speed of the, if it was an hyperindex or this.
No.
It does. It mentions the block interval here.
Nice.
But this radar thing was actually adjusted to be more visually friendly because Monad would be going looking like a fan. Um, so it's normalized for visual effect.
Nice.
Um, but it's cool. You can see USDC transfer volumes. Monad is fairly high on the USDC transfer volumes, understandable. Base pretty large, and Ethereum mainnet still the kind of titan of security and value transfer.
It's quite interesting with Polygon with 2.8K, considering like how Polygon is one of the, maybe it's on the USDT side.
Yeah, there's a lot of factors that don't mean this data is too meaningful. Again, different times of the day, different factors. Polygon often, because gas costs are really affordable, you might find there's a lot more frequent, smaller transactions. Um, and yeah, a couple of factors. And I think this is a moving average, so it's not. Again, it's only live from when you open the site, though, because unlike Hyperindex, we're not saving the historical data. We're just doing
Yeah.
a query in real time and doing a kind of aggregation. All right, so if we were to build this and we wanted to use Hypersync directly, the first thing we would do is we'd come over to the documentation and we'd probably read it a bit. But I'm going to skip and show you a nice tool. It's in our documentation too, which is a Hypersync query builder. So it's helpful for building out your queries when you just want to test and get an idea of the data points you want. What's really nice is we have all these presets. So I'm not going to fill it in manually for now. I'm just going to start with the preset. I want to pull, since we would be doing something like USDC, we would pull ERC20 transfers for a specific address. It makes sense. We just have the address as USDC. All right. And you can see we've got our filter here. This is especially specifying the query filter. And what it does is it creates this query for you here. This is what the actual query looks like. It might look a little bit intimidating for now, but it's actually super simple. This is the transfer topic specifically. And we are filtering by transactions from and to a specific address. So we're not just asking for any transaction, we're asking specifically for an address. And then the data points that we're asking for back are the block number, timestamp hash, transaction, et cetera here. And if I wanted to, I could also just tweak this and let's say I want to add some more fields. I want more block fields. I don't know, I'm going to click some random ones. So I'm expanding that query and you can see now our field selection is more expansive. So depending on your specific use case, maybe you want to calculate like total gas or et cetera. I can then execute this query and we get some data back. Now, as I mentioned, Hypersync is a little bit of a layer below. It's more raw data, so it's a little bit less developer friendly, but more flexible. So depending on which layer of abstraction you need to sit at, you might go a layer below. But you can build really cool, really powerful things with Hypersync, including an indexer, for example, such as HyperIndex. Cool. I'll pause there quickly if there's any questions.
We have GMs in the chat, so if you want to say GM back.
GM. Cool. Then maybe to go a little bit deeper into Hypersync specifically, again, I strongly suggest checking out the showcase. For me personally, I find it easiest if we actually just look at practical examples and see it in action to help understand, what are the different use cases. I would say predominantly most of the time you might just use Hyperindex directly, but there's also a lot of applicable use cases for using Hypersync. Using Hypersync directly will also be faster. in many reasons because there's less additional stuff happening on top. Here again is a query builder if you want to check it out. Now, as you saw, Hypersync has a different query interface than RPC, so it's more flexible, more custom. It lets you do more complex searches, but it is different from traditional RPC. And that's where Hyper RPC comes in. It's kind of like an RPC interface. One of the major performance optimizations that comes with Hypersync is the fact that we're not sending data over kind of JSON API, right? So what I mean by that is your internet bandwidth is limited to a certain bandwidth. Okay, it can support a certain amount of data that gets transferred over it. Now, when you send like RPC requests, you're sending the data semi like raw, or let's say uncompressed, over that internet cable. And if you're doing a lot of data transfers, obviously, if you've got uncompressed data, it becomes a little bit of a bottleneck. Now, a super simple optimization is we send data as a binary packet transfer. Just think of it as, instead of sending these big kind of data chunks over, we compress it so it's much smaller and are able to send it over the line by really like bulking it up together so we can send more data. Now, if you do this type of transfer, you need to be able to decompress it on the other side. And that's why we suggest using something like a client. Now, a client is like a software library to essentially decompress the code, that raw binary packet transfer. Now, the clients do a little bit more than that, than just kind of decompressing it. They have some nice kind of friendlier APIs or interfaces for handling that data. Okay. And if you are a Node.js developer, you've got a Node library. If you're a Rust developer, we have a Rust library. You can use Go. It's a community built library, or you can use Python. So really friendly to the environment you're working with, and a great way of getting that data efficiently and performantly is by using a client. And each client has its own documentation to help you get started. I personally find the examples the best source. So if I click here, you'll see lots of really nice, simple examples you can use to kind of replicate or do what kind of makes the most sense to you. Cool. That is Hypersync in a nutshell. Obviously, playing around, you can go as deep as you like. One thing that's important to note is you need to use an API token. That's in both HyperIndex and Hypersync. It is completely free to use an API token. You simply come to the hosted service. Let me just follow that flow again. I go to the hosted service. You log in with GitHub. I click on the API tokens here. You'll have a chance to create it, and then you can copy that token. And then all the clients essentially make that clear in the documentation on how to use it. Alrighty, we are a little bit ahead of time, which is great. Open the floor to any questions. Otherwise, I'm sure we can wrap things up slightly early.
I have like couple of questions. Like you mentioned about the hyper RPC, and I believe like it's only the read layer. Like you cannot like write like contract functions or anything like that compared to other RPCs, right?
Yeah, yeah, yeah.
Or looks like
Sorry, I think my network dipped for a second there.
I thought like it was mine, and I was looking at like okay.
So with HyperRPC, we've built the technology that we can also make it an end-to-end RPC. At the moment, we're very much focusing on HyperIndex, so that kind of product offering. but it's not impossible to see in the future that Hyper RPC will be an end-to-end RPC. At the moment, Hyper RPC is free. It's really friendly for developers to play around with. It's very fast for accessing data. Um, there's some great benchmarks out there and screenshots from being a provider in DRPC as well to see it specifically for data-intensive tasks. Um,
I think if
but
you
yeah,
just wanna show the data on the UI, like hyperpc, it does make sense. Like for example, revoke.cache also like primarily like wants to show the data of what all token approvals you have given to different tokens and at what spender allowance you have done. So for all those tasks, I think like could be really good to use hyperpc or hypersync.
yeah, for sure. So I can let me know if you can see my screen. I'll just start sharing. If you take a look at the documentation, let's click here, HyperRPC docs. You can see there's obviously a lot more context to it, also suggestions on when you want to use RPC or when you want to use hypersync. Again, by using hyperRPC, you don't benefit from that compression because RPC protocol doesn't have compression. Unlike gRPC, that doesn't seem to be very well adopted in the blockchain space. And then you can see the set of methods that are available to you. So a bit more plug and play, a little bit slower, but also a really nice way of accessing data.
Nice. I think like I heard the story from the edit and like story behind like why you created the Envio.
Yeah, so just to understand that question correctly, you asked about a little bit of background to why we built out Envio.
Yeah,
Cool.
I think quite interesting story to know.
Hmm, I think so too. So we, my two co-founders and I have been in this space for about 7 years or so. We've done quite a few different fun projects, and we've done some consulting as well, building out applications for other teams. And we were quite heavy subgraph users. And as I said, in 2019, subgraphs were amazing. This really friendly framework for indexing data, a lot of it managed for you. And as time progressed, networks got faster, more apps became multi-chain, became very more the common case. You look at, for example, Sablia, who has 20, they support over 20 networks with 4 indexes. What's that? 100, sure, that's 80 deployments that they've got to manage. It's a huge amount. So, um, a lot of these kind of pain points, we still got a grant from the graph back in the day to build out subgraph and Crashable. But at the end of the day, we were waiting about a week. We were working on a derivatives trading protocol. We were waiting about a week for our indexer to sync. And at the time, we were very much panicked that, if we have downtime, we're going to have to wait a week for this to go out, or we'd have to wait a week to build out a new feature. And what happens if that feature goes out and there's like, oh no, wait, there's something wrong with it. So the developer experience of waiting this really long time was becoming more and more of a pain point. And so at the time, we started building our own custom indexer specifically for ourselves. And we were going through a little bit of a challenge with our kind of the dev team was very much waiting for external sign off. And so during that time, we've put a little bit more focus into generalizing our indexes so that other teams could use it too. And that's kind of where Envio came out of. And we found a lot of really great feedback. I think there were some initial teething pains in the early days. I think that's very standard of new tech. Excited to say the products have definitely matured quite a bit, and we have a really shit hot hosted service where we manage and maintain indexes for really cool teams. Aerodrome, Velodrome, Sablia, Ostium, ZK Pass. I'm just name dropping now. Yeah, and that's kind of the backstory to how Envio came to be.
Nice. That's quite an interesting story to know. And I think like that also shows up in like when you want to use hyperindex or hypersyncs, you can see like how easy it is to like use it because you have the CLI, you have the builder, and making the developers' lives like more easier and like making developer journey a fun rather than like waiting for a week to
Yeah,
just.
for sure. I gave a talk on it at Pragma in ETH New Delhi, but I just spoke about modern blockchain indexing, and I think it covers three pillars. One is performance. We in an era where networks are getting faster and faster, and we have more historical data to sync through, so speed. The second one I mentioned now, Sablia, is multi-chain. Unless you're worried about fragmented liquidity, you usually deploy onto multiple networks. And third is one that I think is actually very underplayed, which is flexibility. So something I didn't actually show you in this demonstration, but because the handler functions where you do your kind of event processing before you write it to your database is an asynchronous function, you can handle off-chain interactions. So you can fetch data off from an external API and return it, or you can do things with a lot more flexibility. Likewise, you can also do things like sending data to a queue. We've seen people using Kafka. We've seen people writing to RabbitMQ queue. We've seen people pinging Telegram channels for like a notification system based on some kind of event. This speaks to kind of flexibility in the sense that there's much more advanced use cases than purely like event and save uh, type situations.
Nice. I think like we saw that, right? Like where you created the stats database as well, like giving you the flexibility to like have your own database of other data that we're getting from the chain.
Yeah, for sure. Um,
Okay.
and yeah,
I think we did have like one question, which was like, what are the future plans for Envio?
yeah, great question. Love that segue. Cool. So currently, we very much focusing on iterating on hyperindex, and I think the exciting stuff that's happening on that side is we are exploring our V3. So something very important to us is following semantic versioning, and so no software is entirely without bugs, but we essentially implement upgrades with backwards compatibility. So there's no breaking changes. Hence, it's like very straightforward. Now, once in a while, we'll have a major version change, and that will come with some breaking changes. So there'll be a bit of a migration guide. We're currently on Hyperindex V2, and we're soon to announce actually V3. There's some behind the scenes things if you're going through our code a bit closer. And I think the major exciting thing that's happening there is twofold. One is Solana indexing, so applying it to not just EVM but also Solana. Apparently, the data space is a nightmare. And secondly, is using ClickHouse as a sink rather than PostgreSQL. And it really speaks to as your kind of data gets bigger and bigger, you start needing to focus on querying optimizations, so actually reading the data from your table, because now you've got a big table to go through yourself. And ClickHouse is very performant for this, so we get better query performance. And then an additional note is you get massive storage compression benefits. So a light kind of litmus test on it, we saw 20x reduction in storage. So for example, if we are working with Binance on their PancakeSwap V3 subgraph or indexer, that's around 2 terabytes of storage. Now, 2 terabytes of storage is quite a lot to, well, it's fairly decent versus a very, very manageable 100 gigabytes. So I don't know, math doesn't work quite perfectly, but um, yeah, it's a lot more friendly on storage size. And then, yeah, new network supports on the hypersync side, adding more traces supports, and then, yeah, continually improving our hosted service.
Nice. So I think if you want to summarize, Envio will be getting more faster and faster, more performance
Yeah,
benefits, and more chains to come.
absolutely. Yeah.
Nice. So If you have like not registered for the hackathon, we still have like more than 22 days to go, and you still have a lot of chance to like learn about Envio, learn about the MetaMask advanced permissions, and participate. So let me share my screen. You can like scan the QR code and like join the hackathon if you have not joined already. But thank you so much for the session, Danam. It's like it was really like amazing session. Like loved how you like asked like what context you wanna index and like you build the indexer, did all the stuff with that. Really good to see. Also loved
Yeah.
the radar.
Thanks. Awesome. Yeah, definitely check it out. I'm glad the demo went quite smoothly because sometimes there's some hiccups or catches that you don't really want to debug on live screen. But yeah, that across case was very nice to look into.
Like,
Yeah, and thanks so much for having me and Envio.
okay. Thank you so much everyone. See you next time.